Hello everyone, welcome to the Code. And in this part, I'm going to teach you very important stuff. That is integrating the third-party API and creating the caching mechanism for your FastAPI backend server. These 2 points will create your server more optimized and more featureful. So how we are going to do this? So let's see what we are going to learn in this part. So first of all, I'm going to explain you how this caching works because when we know it, then it is easy for us when we are going to implement it. After it, I'm going to show you the small project setup on which we are going to do the development. And the third thing is when we are taking some any third party API, it means they will give you some kind of authentication key as well. Because of that that authentication key will enable you to use that service. So we will see how to secure it. Actually, we did it earlier, but it is good to keep that in practice. In fourth point, we will going to actually integrate the third-party API to our existing framework. And also, how we are going to do this? We are going to use the HTTPX library, and I will explain you why we are using the HTTPX only. Why not anything else? And the last part, we have so many libraries for the caching, like this LRU cache and FastAPI cache too, which was provided by the FastAPI. But these all caching libraries provide some different work, and I will explain you what these works are, and we are going to implement it in our code, and also in practical we will see how this caching works. Okay, so first of all, what I will do, I will explain you how this caching works. So for that, what I will do, I will come here and I'll open this marker. Okay, so here I have this. So for it, what I have is this user. This user is the one who is using some device, and this device is running. This device can be your phone, this device can be your laptop or desktop, anything. This device is running some application. Okay, and this application is utilizing your fast API, the API which you created on the FastAPI framework. Okay, so here is the user. User have his device, and this device is running some application. This application is using the API which you created from your FastAPI backend server, sorry, framework. Okay, so here is the server. This server is the one which is the main engine which is running the FastAPI server. It is the FastAPI server on which your FastAPI application is running, which is providing the APIs. Okay, so what's the normal request response cycle is? When user is asking for something, this application will send a request to this server, and then server will process the request. After processing the request, this server will send back the response, and this response will be read by the application, and this application will show the required data to the user. Okay, so it is a normal flow which we uh, observe on day-to-day life. But what is happening at the backend? So let's take an example. User is asking from the app, like, what is 2 plus 2? So this 2 plus 2 data will be sent through the request to your fast API server. This fast API server will so this fast API server will process this 2 plus 2 equals to 4, and this 4 will be sent back as a response to the user, to the application. Okay, so now user have this data 4. But let's say this same user is coming again to the application, and it is asking the same input again. It is again asking, what is 2 plus 2? Then what will happen? It will again, this application will send this 2 plus 2 to your fast API server. This fast API server will again do the process. It will again provide the answer as 4 after processing the request. And then again, it will send back the response to your device, to your application, which is consuming your fast API. So for the same kind of request, for the same input, this fast API server is running multiple times. Like for each request, this fast API server will do some kind of computational work. It will consume some resources, and it will provide the data. But is it good? No, it is not good, because if this particular server is already processed some input, then it should not do the same process again and again and again, because this is the repetitive process and it will consume the server resources. And when it consumes the server resources, it means it will increase your cost. So what's the solution? So here is the solution. So let me remove this thing and this thing. Okay. So what's the solution is? Solution is this caching layer. What this actual cache do? It is the caching layer, or you can say caching server. Actually, it is a database which store data in key value basis. Okay, so I have this caching server, which is actually a database, and this database will store data in key value basis. So let's assume at first time this user is asking with the request like what is 2 plus 2. So it will come to the caching layer, the cache server. Let's assume this application is just started now. This caching layer is empty. So it will check for this 2 plus 2 here. It will not find any kind of data. Then it will send it to the FastAPI server. Here it will do the process 2 plus 2, generate the result 4, and it will send it back through the caching layer to the user. Okay. So right now in the first cycle, this FastAPI did the process to do the computational work. Now let's say user is again asking the same 2 plus 2. So what will happen now? The user will send the request to the FastAPI server. It will be 2 plus 2. But this time, this caching server, which is working as a database, will check, okay, this key, this 2 plus 2 is there or not. Actually, it earlier did the process for this. So it will find, okay, 2 plus 2 is here and its answer is 4. So it will send back the answer 4 to the user as a response immediately. So what profit we got? The profit we got is we saved our server to do some unintentional or not required computational work. We saved our resources, and also it speed up the response time of your application too. So with this caching layer, we got so many enhancement to our application. We optimized our application in a way that the user will get the faster result, and our server should and our server is not doing so much of work. So this is the concept of caching. And now we know how this caching works. Let's go for the second part. What is the second part? Let me come back here. Where is the slide? Okay. The second part is, okay, let me close it first. Fine. So the second part is project setup. So what is our project setup? Let me come here into the Chrome. Okay, so we have this. Okay, let me come here. Okay, so we have this actual Git repository already on which we are doing all the development. So this particular Git repository I will provide you in description. It have all the code which we required. So if you go to the dev branch, you will find these many folders. Inside the API, you will find all the APIs which we created. Actually, it's a e-commerce platform based backend services. So for the e-commerce, there are four main pillars, that is category, product, user, and review. So we created the API for all of them on the Fast API framework. So what I did, it's an open repository, anyone can clone it. So what I did is I just my VS Code. Okay, here it is. So what I did is I just simply clone this particular repo. After cloning this repo, I just checked out to the dev branch. After checking out the dev branch, I just install all the requirements which I need to run this Fast API framework services. So these all the libraries which is installed right now, and we can start the development on the go. So this part is clear as well. Let me go back here. Now let's come to the secure API key handling. So how this secure API key handling work? So for that, what we did is inside the core, uh, in the naming convention core, it will do all the core work. We created this config.py. Inside this config.py, we use the pydantic base setting. This pydantic base setting is used to get the data from your .env file. This .env file we created here in our repo. Inside this .env file, we need to provide key equals to value, like the secret key equals to whatever the secret key value is. Algorithm equals to algorithm value. So what this config.py will do, we created a class setting. Inside this setting, we inherited the base setting from the pydantic setting. So this, if it is coming from pydantic, it means we need to create the structure as well. So whatever the key we are providing inside this .env file, or all those security key which we want from the setting, that we need to declare here, like this database URL, the secret key, and algorithm. This database URL as well should be inside the .env file. I just keep it here so that in the last part, when we are working on the deployment, I will remove it. And again, this part will be clear for all the viewers so that they will remember it. But I will remove it from here. So from this class, what I'm doing is I'm just putting all the keys into the env, and I'm reading that env file while using these keyword, like this database URL, this secret key, and algorithm. The setting is equals to setting will create the object, and whenever I want to access any of these variable like this database URL, what I need to do is I just need to call the settings, like from .config import setting and setting.database URL. So in this way, I just secured all the sensitive keys, and I'm not hardcoding anything. Okay, that's good. So in this way, we are going to secure the third-party API key as well. So what we will do, we will just create the, let's say, API auth key here. API auth key. Let me remove this J. API auth key. Let's say some XYZ for now. And this API auth key, we need to put it here as well as string or whatever the format it's there. Okay. So this is the way we are going to secure our API keys. That's it. So we just secured our API keys as well. Now let's come to the part of asynchronous API calls. Okay, so for the asynchronous API calls, let's go to the third-party API. We need to consider a few things first. So there are two ways to call a third-party API in Python. So if you want to call a third-party API, it means you need to create some kind of request to that third-party API. And there are two ways. First, using request lib, and second, using HTTPX. Sorry, it is HTTPX, not HTTPS. From the request library or request module, that is like simple import request and request.get that particular API endpoint, and you will get the response, whatever the data you need. And from the HTTPX, you need to create a client first for it. But there is difference. What is that? This request lib is for the call API synchronous. It will call the API synchronously. And this HTTPX lib will call the API asynchronously. And we are working on a fast API framework, which is working on asynchronous manner. So if we are using this request library called API synchronous, what will happen? I will just demonstrate you. So let's say it is your fast API app, and this fast API app. Okay, let me open that again so that it will be more easy for me to explain. Okay, so here it is. So here is your fast API app. Let's say you are using this requests module to call that third-party API in a like request.get and that third-party API and endpoint URL. So what it will do, it will receive a request A. It will start processing request A. Let's say you have some method def API call. Let's say you have this API call method, and inside this you are using this request.get. Inside this you have some URL of that URL. Okay, this URL. This URL is something when you are requesting for service A, what it will do, and you have some kind of code here, some code above it. So what this line will do, when you call this API, it will stuck at this line until it will not get any kind of response. When it gets the response, then only it will let you to execute any other line. And in the fast API asynchronous behavior, what we did earlier is we created all the API in async. Let me clear it. Let me clear it. Let me change it as well. Okay. So we created all the API. Uh, okay, fine. So we created all the API. Okay, again, we created all the API in async. So this particular method is open to take any other kind of request. But let's say if a user is calling this same API second time again, and the previous response is not generated, then the second request will come inside the queue, and it will wait for this response to get completed. It is not the correct way for the fast API framework. That's why we should not use the request module in fast API framework. So as explained here, so it will block the complete cycle of this request response. And when it receive the request B, receive response from the external API, when it will sorry when it complete the response of request A, then it will start the process request B. It is the complete different nature what we are expecting from the fast API. So what's the solution? The solution is using the HTTPX library. So what we'll do, using this HTTPX, the request A will come. After when the request A will come, it will go and do the call with the await. The async method will do the await with the HTTPX. This await and this await and async, these two keywords make your API asynchronous. Okay, so this async and await combinedly create the API call to your third-party API, and it will wait whether the response is coming immediately or it might take some time. And at the same time, if request B comes to your API, it will start processing that request too. So we achieve the same asynchronous behavior with the HTTPX, which we are expecting from our fast API framework. The asynchronous behavior for which we use the fast API framework. Okay, so this is it, like why we need to use this HTTPX. Let's come to the coding part. So to integrate this third-party API, we need to do some modification to our code. And to do that, first of all, we are going to install this HTTPX module, which we just discussed. So what I will did, pip install HTTPX. Okay, it should install all the required library. Okay, that's it. And after it, what I will do, I will just start our server. So whatever we are going to develop, we will see it in a real time. So uvcon main slash app hyphen reload. Okay, so it will start our server. Okay, that's it. So our server is running right now. First of all, what we need to do is we need to create one client which will represent our HTTPX, and that particular client will be used for all the third-party APIs. So inside the core, I will create one file that will be called as httpx client.py. Okay, so I have this file, and what I need to do is I need to import httpx, and after importing it, I need to create one async method. This async def get httpx client. Okay, this get httpx client, and inside of it, I need to create one one object of this httpx asynchronous object, and I need to yield it. So what I will do, I will just do the async with httpx dot async client, where it is async client, and async client as client, and I will do the return client. Okay, where is this client? No, not like this. This client. And also I need to do one thing. I need to define what should be the return type, so it will be sure whatever we are returning from this method. So for that, what I need is one more library from typing import async generator. Async generator. Okay, this is the async generator, and let's create this async generator, which will have either this HTTPX dot async client or none. Okay, fine. So we created our HTTPX client. What these lines are doing, this particular line, it is representing that this method should generate a async object which can have only of these two type of objects. Like what? This either this HTTPX async client. This async client is the one which will help us to uh, create the asynchronous API request to the third-party API, or either none. Okay, so this is the one part. Second thing is, let's use some very simple third-party API where we do not need much of security or something. So what I will do, as I have in this .env file, I have this API auth key, and I need to modify one more thing. And what is that? I need to do here is, okay, this one. Okay, I need to create one method from which I can return the settings, because from now what I will do is I will call this settings inside the method to fetch that key. And if I'm going to use this object, is this instance of the setting class, it will be not callable inside the dependency injection. Okay, so it's really simple. Get settings. Okay, inside the get settings, go here and return settings. Okay, fine. That's it. So this is the thing which we need to do here. And if I'm changing something here, then it means I need to update it here as well in db.py, because I'm using this database URL from the settings. So from now, I will not import the settings. I will call the get settings. And here, as it is a class, so what I will do, this get settings dot database dot URL. Just to verify it, I will do the dot, and it should provide me all the things which it have. Okay, so this database URL will work from here. So I have this HTTPX client, and I updated my settings as well, so that I can retrieve all these env variables in our dependency injections and other and in other services as well. So to create the third-party API, what we need is, we need to create one folder at the root level. Okay, I will create the uh, external services. Okay, so it is the external services. Inside the external services, what I will do, I will create one file. Let's say this file is weather.py. weather.py. Okay, inside the external services, I created the weather.py. And from here, what I will do, I will just write some very simple code, and we are going to see in the postman whether this particular API is running or not from this FastAPI framework. Okay, so from FastAPI, what I'm gonna need is, from FastAPI import depends, because I'm going to depend this settings. The settings will be dependent, and this HTTPX client will also get as a dependency. Okay, so these both will go inside the dependency injection. And now what I need is, from core.httpx client import get HTTPX client. Fine. From config from core dot uh, from core dot config. Okay, import get settings. Okay, that's it. And one more thing I need is import HTTPX. Okay, import HTTPX. Why I'm going to need it, I will explain you. So let's create the method. This will be the async method. Async def Okay, okay. Fetch weather data. Fetch weather data. And what I'm gonna need is the city name. City name. It will be of a string. Okay. Then settings. Settings will be of type. Okay. I need one more thing. I need the class as well here. Settings from the core config because I need to define what type of this particular settings is. So it is the so it will know like what kind of data I will get. Okay, so let's call it settings, and this settings will depends on get settings. Okay, and one more thing which you're gonna need is the HTTPX client. So I will create the client as well. This client will be of type HTTPX dot async client, and it will depends on where is this get HTTPX client. Okay, so I just created all these things, the input which I need. Now let's do some simple coding. So, okay, let's do the base URL. Base URL equals to, okay, this is the base URL. Fine. Params. Let me copy the params. Let me copy the complete code so that I can explain you in more faster way. Okay, so here is the complete code which is required for this uh, fetch weather data. So what I need to do is I need to update few things. So inside of this base URL, I need to update this thing. Okay, and for the settings, I'm using this settings. So I will use the settings.api auth key. And in place of API auth key, what we are using API auth key. Okay, that's fine. That's fine. API auth key. Where is that? Weather.py. So what it is doing is you can modularize these two things also as this params. It is the latitude and longitude which you're gonna need from the user to provide. Actually, user will not provide. What user will ask you, okay, just give me the weather update of Delhi. So let's say if the user is asking for the Delhi, then your front end will do all the work for to fetching the longitude and latitude, and that particular front end will send you the longitude latitude to this backend API. Or you can create one more service from the city name. You can extract that latitude, longitude, and that you can extract here. Okay, so for now, I'm just using it for the demo purpose. So that's why I hard coded it. So it is the latitude, it is the longitude, and it is the current weather, which I'm using as true. It is one open API. It's not, I will say open API. It is the API which we can use for the dummy work or demonstration work. So I have this base URL. To create a GET request, what we need base URL. We need query parameter because we are fetching for something specific of one particular area. That is your query parameter, which we are passing through the params. And the third thing is header. Header will contain your authentication key, which we have just provided here. So what we need to do is we just need to put the await with the client.get. This client is coming from the HTTPX, and we are providing all the input variables, which, sorry, all the inputs which is required to do the get request. After doing the get request, we are taking the response.json. And if there is anything issue, then it will raise the exception as well. Okay, so we created the method, but it will not work as API. So let's create an API for it. So what I will do, I will come inside the API folder. I will create one API that will be called weather.py. Okay, weather.py. So to create the API, we are gonna need few libraries. Let me paste it. Okay, it will do the work. This depends and fetch weather data. Let's create the API. Okay, so what it will do, weather get weather data inside of this. What I'm gonna need is this get weather data will take the city name. Okay, this city name should be str. Okay, the city name, and then what I need is the settings. Setting will be import from the from config from core.config, import get settings, and this will be of type setting class. Okay, from HTTPX, from core.httpx client, import get HTTPX client. Okay, so it will be of type settings like we did it earlier. It will depends on get settings. Okay, that's great. And then after we need to use the create the client. The client will be of type. We need to import the HTTPX as well here. HTTPX. Okay, this client will be of type HTTPX dot. Where is this HTTPX dot async client equals to depends on get HTTPX client. Okay, so we are just creating the API here, and what it will do, whether underscore data equals to, okay, I need to call that method which we just created from external services dot weather import fetch weather data. Okay, okay, so I already imported it. Okay, then we don't need to use it. Just simply we will call the fetch weather data, and this fetch weather data should become with the await. Okay, should become with the await, and inside the await what I'm gonna need is the city name, comma settings, comma client. Okay, and what I will do, I will just simply return it. You can create some model for it, some schema for it, which you can use as what you are going to represent as to the user. So I will just copy this variable here and here. Okay, so we have this weather dot API. Okay, let me add the router as well. Router dot get. After the get, let me add this slash bracket city name. Okay, let me just close this bracket and close the braces. Okay, now this particular API is completed. What I'm taking is the method which I created at the external services, which is doing all the action for me. I'm just putting the await for it, and I'm creating the asynchronous API with the help of async. Okay, so this async and await will provide me the functionality, and it's already doing the asynchronous work for me. Okay, so that's it. And what I'm gonna do is we are just now let's check the API from the postman. So here it is, and where is the postman? Where is the postman? So here is the postman. What I'm providing, I'm just doing the get request on this API URL, API v1 weather or Delhi. And what is the endpoint we are expecting here? This API v1 weather and the city name. The city name, from where I got the city name, the city name. Okay. So let's hit the send button and check whether it will work or not. 500 internal error. Let me see why it happened. Okay. Runtime error, cannot send a request as the client has been closed. Okay, so the client has been closed. It means it is something related to the HTTPX client. Okay, I just misspelled it to HTTPX. I will update it. Okay, so the main issue is I use the return here, and this return, what it will do, it will close the connection once it is executed. So what I need to do is I need to provide the yield here in place of return so that it will not close the session until it is not completed. Okay, so I guess it should do the work right now. It should do and it should start the server. Okay, the server is started. Let's go here and do the send request again. Now we get the results. Yes, yes, yes. So the third party API which we just used is providing me the result from our FastAPI backend endpoint which we created, and it is working in the asynchronous way which we made sure. Okay, So it is the part where we did the work on the, let me go back here. Okay. So we just created the asynchronous API calls. So the last part comes here into the picture where we are going to use the caching mechanism for our fast API backend. So to do that, what we will do, we will come back here and we are gonna start with our setting.py. So not setting.py, from get setting. So what we are going to do is we are going to understand a few concepts, then and also we are going to implement the code in the parallel. So in the settings, if we see, we are just fetching this, where is the env file? We are just fetching the secret key, algorithm, and API auth key from the .env and config.py after doing the get settings. So whenever this weather.py, this particular API will be called, this API will call the fetch weather data, and this fetch weather data will go inside the client.get, and inside the header we are using the API auth key. Whenever a user will come and do this request, the request will go every time to the server, search for this API auth key, and then it will execute. But it is not the optimal way. We need to store that API key somewhere at a place where it do not need to go every time to all the configurations. We do not want to read configuration every time. We just want to read that configuration one time because that contains some sensitive data. So what we need is we need to create one kind of caching mechanism for it. And how we are going to create a caching mechanism for the get setting. As we can see, this def is not after the async. It means this particular method will work in the synchronous way. And for the synchronous way and to caching all the configuration related setting, so what we need is from func tools, import LRU cache. It is the least recent use cache. Okay, so this is the least recent use cache. All we need to do is we just need to provide the @LRU cache to it, get settings. So whenever this it will create one cache at your server. Because of this, whenever something needs this API key, it will come to this cache after the first execution. And after the first execution, it will read that cache from here. It will not go inside the config keys. It might be possible that you might have thousands of config keys, and it might take few milliseconds to read from all those config keys every time whenever a user is sending a request. So it will save that data, and it will use that all the recently used API keys or configuration keys, which is getting used by the API, it will save it there, and from there we will use it. Okay, so it is the LRU cache. Now let's come to the part of where we are going to discuss where we should use the fast API cache with Redis and why we need these two, fast API cache and Redis. So these two serve different purposes. Let's say fast API to cache in a restaurant, this fast API to cache is the chef. The chef will decide what type of dish is to be created from the kitchen or should we go inside the menu. And this Redis is the one who is writing or removing the data from the menu. So from this explanation, we can understand the fast API cache 2 is the one who is responsible to decide that which data will go inside the caching. And this Redis is the one which will do the uh, process to get the data from the cache database or to store the data into the cache database. But which data will go inside that cache, it will be decided by the fast API cache 2. And why we are using this fast API cache 2 with Redis? Because again, we need something which will work with the asynchronous requests. Okay, so this is it, and let's implement it. It is really easy. It will not take much time. So we already implemented the LRU cache on the settings. Now let's time to create the cache for the fast API APIs. So before going to do that, let's discuss few things like what will be the plan. So the plan will be like, first, what we will do, we will make the context manager, which will handle the life of caching server. What this context manager will do, let's say you have this fast API application server, and we need some server which will handle the caching. So this context manager will do the work of initiating this Redis server and terminating this Redis server gracefully with the start and stop of your application. So we need this context manager. Whenever your application is start, it will start that particular cache. And whenever your application stop, it will stop that particular cache gracefully. Okay, second thing, when we are done with the context manager, then we will integrate this caching server with our fast API instance. So the instance which we are running through our UV for the particular app which we are creating using the fast API, that we will integrate with our caching server. Okay, so right now we created two things. The first thing is we created the caching server. The second thing is we integrated that caching server to our fast API. Now the third thing is we are going to implement that cache to the API request which we have or which we created from the fast API framework. Okay, so now we have these all things, but still there are a few things. Let's say there is a user which who created some data at your database using post API, but at your caching server there is some data present from the get request which have the older version, because this particular post request created the newer version of data, or it just added a new data. Or let's say user is running some put request or delete request, then your data which is present inside your database, which is a valid data, it got changed. But in your caching server, it have that old copy of that data. So we need to take care of that thing too, so that whenever a user is going to hit a post, put or delete request, then the same key value should be deleted from the caching server. And when some next user will come and hit the get request, then the latest copy of data will come and store inside the caching server. Okay, so this is the thing which we are going to do. It will not take much time. It is just a short code. So let's start. Okay, so here is our application, and let's go directly to our main.py. So what we will do, we need to create some context manager. So for that, I will import fun library, this import context lib, sorry, from import. Okay, from context lib, import async context manager. Okay, and I need something from fast API cache dot backend import import Redis. Okay, I need this Redis. Yes, Redis backend. Redis backend is not there. Fast API cache dot backend dot Redis. Okay. Backend dot Redis. Import Redis backend. Okay. Then I need one more library from Redis dot io dot iosy import import router. Okay. Import. Okay, not sorry, import. Okay, we just import directly. Import redis.asyncio as Redis. Okay, I guess this will do the work. Okay, we gonna need some settings also. Okay, then from core.config import get settings, and okay, I have this settings. I have this Redis context manager, fast API cache also I'm gonna need, and from fast API cache um, import fast API cache. So I have all the dependencies which is required for it. And now let's create the method. What we will do, we will create the async def lifespan, lifespan, and inside of it, first of all, we are going to use the async context manager as its decorator, so that it will work as a context manager, which we discussed earlier. which will take care of its life, like when it will start or when it will end. Inside the lifespan, I'm going to take the object as app will be a fast API object. It is the app object, which will be type of fast API object. Now what I gonna need is, I just need the Redis client. Okay, Redis client, Redis client equals to Redis dot Redis dot Redis. Okay, fine, Redis dot Redis, and then mm, all I need is just the host. Host equals to, let's say for now we have the local host and the port. Okay, we can take port as well, port 6379 and db equals to 0. Okay. So we have this, it will create the Redis client. And now what we will do with the Redis client is, I gonna need is the fast API cache dot init Redis backend. Inside this Redis backend, Redis client, comma prefix equals to fast API cache, fast API cache, and then just yield, Y-E-E-L-D, yield, and then this yield, after this yield, await Redis client dot close. Okay, I will explain you what I'm doing here is, the part which is above the yield, this one, it will be uh, it will execute when when your server will start or when your application will start. After the part of this yield, this particular line of code will be execute whenever your application got closed. So this yield is like a middle point, and it will decide whether your application is running or your application is getting closed. This particular thing will initiate your Redis server as a fast API cache. So this is it. This is how we are going to create a fast API cache. Now it's time to integrate this lifespan to our fast API. So what we have here is, we have this already app equals to fast API created. Then what we gonna need is, all we need is just to do the add few things, and that's it. So we can say all we need is the lifespan equals to lifespan, and that's it. Lifespan equals to lifespan, or else you can provide any metadata also. So if you want, like, you can provide the title of your application. So it will be like this, fast API ecom, and there will be some kind of version, so you can provide that as well. So what I will do, like here, version equals to let's say 1.0, and it is the lifespan which we just created above, that is we are calling here. Okay, so in this way we just integrated the fast API with our caching server. It is that simple. And once it is done, now let's go to our get API, where we can do the caching, because most of the time when user is going to do the get request, then the data which is already present, uh, they can request it and they can get it from the caching server. So that's why I'm putting the cache on the get. So what I will do, I will just come here at the category.py. Inside the category.py, again, it's very simple. So what we're gonna need is, okay, so here I have this, and what I need is just simple few things from fast API, underscore cache dot decorator import cache. Okay, this is the cache. This is the one thing, and the second thing which we're gonna need is from fast API cache import fast API cache. Okay, from fast API cache decorator. So let's say this is my get request where I'm getting all the category from the router. So all I have to do is it's just to come here and add the cache. Everything will be handled by the fast API. So I need to do some kind of expiration also. So expire equals to, let's say 300, 300 milliseconds. Okay, fine. And then the namespace, namespace equals to, let's say, get this namespace. You must use it. I will tell you what this namespace will do. So this get, let's say, get all category list will be the get all category list. And I guess that's it. It is the way you are going to implement the cache at your get API. So what this namespace is? This namespace is something uh, which will segregate the data inside the Redis server. So whenever something, okay, I will explain why I'm using this get all category list. So let's say we are at the post request, and after running the post request, something new will be created at the database. So if something new is created, it means the get data which we already have at the caching server, it got old and it do not have the latest copy of the data which it should have. So what we need to do is we manually need to delete that cache from the caching server. So the next time whenever someone is going to hit the get request, then it will update the data automatically at the caching server. Okay, so here I have this, and what I gonna need is after it, when this particular await thing, this CRUD operation is completed, I just need to put the await here again, await, and this fast API cache dot clear, and the namespace equals to get all category list. I guess now it is very clear to you like why I used the namespace. Because of this namespace, it will create the key value where the fast API will understand, okay, from this get request, the data will be stored in this particular key, and this particular key will be deleted when this post request will be initiated, or else it need to do so much of work. So it is that simple. So we just implemented the cache at our get and post request. Let's implement the same to our third-party API. So where is our third-party API? Let's go to the weather.py. Inside the weather.py, all we need to do is we need to just implement the cache. So from fast API cache import, fast API cache dot decorators import cache, and this cache will go directly to my app. Okay, so at the rate cache, and it will have the expire equals to, let's say, 300 milliseconds, and that's it. It is this simple. So we implemented the cache on a third-party API request response, and also to the category in which we are getting all the data. So we created the API with the caches, and they are perfectly designed. But there's one thing, you need a running Redis server for it. The thing is, the part where we provided this localhost port 6379, it is not just a random port or just a random host. You need a separate instance of this Redis, which will be running at some host, and it will expose some port. So when you have that thing you have to provide in the host and port, and then only your cache will start working on your server. So this is it. If you have any issue, or if you get any confusion right now, please let me know in the comments. I will update you, and in future after this series, I will surely create one episode with this Redis host only, where I will show you all the examples which can be possible or which should be there at your application site. But it is for your general purpose knowledge that how you can implement the caching mechanism if you have all the resources at your hand. So if you like it, then please comment and let me know. And also please subscribe and share. So Thank you, and thank you for watching.